is we'll be studying the length of a line segment. So a line segment is a defined set of points directly between two points. When we're trying to find the length of a line segment, you'll notice that this thing forms a right triangle. Now, if you think about it, you've got a triangle that looks something similar to this with a right triangle in the corner. The bottom portion of this, you'd normally call it B. The other one, you would call it, I believe it would be A. And you'd normally call this C. And you would use C squared equals A squared plus B squared, which means we're using the Pythagorean theorem to find the length of AB. Now, if I use the concept of rise and run from the first unit, that means this red part right here would be the run, and this green part going up would be our altitude, also known as our rise. Now, based on that, if we use d for the length of this hypotenuse, right, and we used run and rise to find, say, the length of the line here, we could say this: the distance is equal to the square root of the run squared plus the rise squared. Doesn't that look like Pythagorean theorem? Yes, it does. And now, let's take a further step here. Imagine that we have A being our first point, like x1, y1, like when we were finding like slope and stuff like this, and B was x2, y2. Okay? What you would have here is you'd have this equation, d equals the square root of run squared plus rise squared, equaling this equation. Now you'll notice that I'm going to be replacing my run and my rise with the x's and y's from this equation here. Now if this is x2 and this is x1, that means the distance between here and here is x2 minus x1. And the same result will happen for our y values. If this is y2 and this is y1, that means the distance from here to here is y2 minus y1. So the distance for any line segment can be written as this equation: d is equal to the run squared plus rise squared, or d is equal to the square root of the differences of the x's and the y's. And that is what I want you to put in this portion of your graph worksheet. So make sure you put that basic equation in. So those two basic equations can be used to calculate the distance between any 2 points. Now, to specifically describe the distance between any 2 points, we're going to go and come up with a nomenclature, a way to describe it so that we know where we got our numbers. So this first example that we have here, calculating the length between these 2 points, right? We're going to determine the length of the line segment, and we're going to use a rise and run type calculation. So let's begin. So in this case, if we're doing the calculation, we actually need to calculate our run. And what our run is equal to is 14 minus 2, and that gives us a final answer of 12. And that's this part right here. Now, the next thing that we have to do is we have to calculate our rise. Our rise is given by y2 minus y1. So y2 is 17, and 5 is our y1. So we end up with this as our final answer. Now, using our base equation from before, we have this: d is equal to run squared plus rise squared. Now, if we want to take that information to the next level, we're going to have to do the following. We're literally going to write a subscript for d telling us where our a's and b's come from. In this case, we'd say d of little ab is equal to the square root of run squared plus rise squared. And we substitute directly in. Now we're going to go the long way around to show you some really interesting math. So imagine we get this. Substituting and simplifying accordingly, you're going to get something similar to this, which is the square root of 288, which can be rewritten as the following. So we end up with DAB equaling 2 times 144. Now, the square root of 2 is not a nice number, but the square root of 144 is. So what we're going to do is we're going to take the square root of 144 and pull that to the front, and then put times the square root of 2 at the end of our solution eventually. So let's take a look at that. So when we do these problems here, we'll note immediately that d of AB is equal to the square root of 2 times the square root of 44, because these two lines that we have here are equivalent based on the multiplicative property of the square root sign. The multiplication under the square root sign is the square root of the two multiples. So now we've got the square root of 2 and the square root of 144. Square root of root 2 is not a nice number. If you punch that in your calculator, you get some number like 1.7 something. But you do know the square root of 144 is a nice number. Now, we tend to always put nice numbers in front when we're dealing with rational expressions, irrational expressions, square roots. So we're going to get something that looks like this. So we end up with the square root of 144, which is the nice square root, times the square root of 2, based on the fact that 3 times 2 is the same as 2 times 3. So we just move these things around. And then when you take the square root of 2, you end up with 12 root 2, which is what you would sometimes call the exact form for that distance. Now, what you could do immediately is just calculate that, punch that in your calculator to say 1 decimal place, and you'll find that you end up with the following answer. D is equal to 17.0 units. Now, because this is a word problem, we always have to go and talk about our final answer. So you'd say the distance between A and B is 17.0 units, because if you looked originally, all this information was on a graph. It didn't say that these distances along the x-axis and y-axis were meters or kilometers. So what you want to do is you want to say that it's 17.0 units.